YouTube. This is Chandu. In our previous lecture, we have seen local variables, instances, and various ways to write the main function and with examples. Now, in this video, I am going to discuss about type conversion. First of all, what is a type conversion? Type conversion means we are changing one data type to another data type, like into float or into long or long to int, and so one type to another. Okay, here conversion of one type. Now type conversion is converting one type of value to another type is called type conversion. Okay, why do we require type conversion? Now for example, if I write some class inside class, if I write int x equal to some 10, sorry, for example, I write long x equal to some 100L. Now this is a very big number, and I am declaring one more variable int y equal to, and I am assigning x to it. Okay, now in this case, long range is very high and int range is very low, and also long uses 8 bits, right? Long uses 8 bits and int uses only 4 bits, sorry, 4 bytes. This is also bytes, not bits. 4 bytes. Okay, now here 100 is stored in 8 bytes, and this 8 bytes cannot be stored in only 4 bytes, right? If at all I want, I can do like this also, int y equal to 100. Okay, this is valid only, but here its representation is 4 bytes. But to convert 8 bytes to 4 bytes, or 4 bytes to 8 bytes, or now 100L. Okay, to convert from one type to another type, we need type conversion. Okay, these are of 5 types. Let's see what are they. Now these are of 5 types. One is widening conversion, narrowing conversion, widening conversion, narrowing conversion, identity conversion, numeric conversion, and autoboxing or unboxing. And these widening and narrowing conversion are further divided into 2 types, primitive and reference types. As I said, primitive data types are 8 and reference are 4. So we will discuss about these reference types later in our object oriented programming, and also these autoboxing and unboxing in wrapper classes. Now okay, let's see what are what. Now first of all, we will go for widening conversion. Before going to widening conversion, remember this diagram. Now byte short int, long, float, and double with char. Okay, here this byte short int, all their left sides are narrower to right side things. All the left side ones are narrower type, and right side ones are broader type. Okay, remember this diagram. Now what is widening conversion? Widening or narrowing conversion? First, widening conversion. Widening, now converting narrower data type to broader data type, right? Now what is narrower data type here? Narrower and broader. Simply narrower. Narrower is a short length. Now here byte uses 1 byte, short uses 2 bytes, and char uses 2 bytes, int uses 4 bytes, 4 bytes, and long uses 8 bytes, float uses 4 bytes, double uses 8 bytes. Okay. Now converting 1 byte to 2 bytes is simple, 2 bytes to 4 bytes is simple, 4 to 8 is simple, 8 to 4. Now here our problem arises, and 4 to 8 is simple. And here from character to int type, this is also we'll discuss in this topic. Okay, now converting narrower to broader is called widening conversion. Converting narrower to broader is called narrowing, sorry, widening conversion. Okay, converting narrow data type to broader data type is called widening conversion. Now here it's an implicit conversion. What is mean by implicit? Implicit means it is done by compiler. We don't need to do it. It is done by compiler. Now here no loss of value. It means if I convert 10 to if I represent 10 in 4 bytes, and if I represent 10 in 8 bytes, both are same, right? Here, see, I will give you an example of the same type. Right. Now now this is an example. Now here I am taking byte. Okay, I am taking byte and converting it into short. See the representation here. Now here byte value is 4, which is 0 0 0 0 0. What? How much? 1 0 0. Right? This is the representation of byte value. Now if I talk about short, how it is converted, it is implicit conversion, right? Okay, this is implicit conversion. Now it is stored like this: 0 0 0 0. Yeah, this in this manner it is stored. Okay, now up to here, up to here. Up to here. Okay, up to here it is actually our byte, and all these are zeros, all these are zeros. Okay, this doesn't affect our value, so it is implicit conversion. And when we come to narrowing conversion, this is narrowing conversion from short from short to int byte, because this is 8 digit 16 bits, and this is 8 bits conversion of 16 bits. Yeah, up to here it's no problem. If I have 1 up to here 8 bits, all ones up to 8 bits. If I have more than here, for example, if I have a value like this, mm, if I have value here in this position, I have 1. See, in this position, if I have 1 up to here, it's no problem, but if I have position here, there will be a loss of value, right? For that reason, narrowing is explicit. User has to do it using typecasting. User has to do it using typecasting, like typecasting. See here, this is the syntax. This is the syntax. Okay, here this is a narrower data type, and the same data type must be present inside parentheses before assigning a value. So now this represents a data type, typecasting, and this value which is converted, a typecasted value, is stored in variables, variable name or variable. Now this one, what is this one? This is a broader one, like for example, if I write here, if I write some long, very long L, I'm giving capital L, long L equal to 100L. Okay, now if I'm assigning int x equal to L, what happens? Now I'm giving long to, now I'm giving assigning long to int, right? So for that reason I'm using typecasting. And here was syntax is actually this is wrong. This is int x equal to, in the braces, int and then L. Okay, this is the right syntax. Okay, this is the right syntax. Here int is a narrow data type when compared to L, which is long, and int is a narrow data type and value by variable is L, or else you can convert directly here 100L also. If 100L is given, it's a value. If L is given, which is a variable. Okay, now int, this is converted to x and stored in integer. Okay, here x is a variable name, int is a narrow type, and L is a, this one, L is 100L, which is variable. Okay, now coming to identity conversion. Identity conversion is converting this a data type to same data type. Like if I have integer, sorry, if I have integer by integer, which is also equal to integer. Okay. Now in these cases, whatever is here is int is converted into int, right? So this is, in this type of situations are called identity conversions, where we require the same type is converted to same type. This is mostly used in for classes, like mm, interface is converted in interface. Okay, next, which is an implicit. Now numeric promotion. Numeric promotion is converting a smaller number type to larger number type. Here byte plus or minus byte is int. Okay, here is an example for it. Here we will get compile time error. This is because now, okay, see this. Here this is byte, 2 bytes, 2 byte values, and I am this one. I'm adding 2 bytes. Okay, I'm adding byte 1 plus byte 2 and assigning to byte 3. This we get compilation error without this. If we don't have this one, okay, if we won't write this byte, then we will get compile time error, because byte plus byte is an int. Okay, in this case we require typecasting operator, which is this one, which is this one, byte. Okay, now here byte, here byte, this is narrower, this is narrower, which is, and here it is broader. Okay, actually this is also wrong. Actual syntax is, sorry, actual program is this one. I have to make it like this, then only it is converted, otherwise you will get again compile time error. Okay, now this is fine. See here, Java C test.java compile fine, Java Java test. Now you get 30, so it is added. Okay, now if I take the previous one, you will get a possible loss of precision error. Now I'm saving, and here Java C test, you will get a compilation of possible lossy conversion. Okay, possible lossy conversion from int to byte. Similarly, we will see some examples here. And before this, I want to talk about one thing: 0 by 0 division, or divided by 0 division. For example, if I have something like this, if I have some 3 divided by 0, what is the value? Actually, this is an error, right? This is an error. Next, if I have 3 by 0f, then this is not the error, this is the right one, this is right. In Java, up to C it is okay, this is wrong, but in Java we have 0f by 0f, these three different values. Okay, 0f by 0f, these three values, 0 by 0 division. This is only in float as well as double, and it is same for double also. Now 0 by 0f, which is a not a number, you will get output as not a number. Here minus 1f by 0f, negative infinity, you will get negative infinity as output. Here 1f by 0f, positive infinity. You will try this as assignment. Okay, this one and one more I will give you now. Now this one, int. Once check this one also, int by 0, anything, int by short or anything by 0, what you will get. If you don't write f here, just check it, if you don't write f in these places, what will happen? You will get an arithmetic exception error. If that is an error, it's a logical error, so we will call it as exception. Okay, now we'll see examples. Here, public static void main string args byte b. I'm giving byte b and assigning b to x. This is implicit conversion. Okay, now byte is a narrower type, int is a broader type. Okay, byte is a narrower type, this is narrower and this is broader, so there will be no problem. Moving on to next one. Here long to float. Here, as I said, I will discuss long to float conversion, because long is having 8 bytes and float is having 4 bytes. Okay, here long is represented using a series of bytes, a series of bits. Now here float is represented using exponential form. Uh, exponential form can hold larger values with small size also. So long can be easily converted to float of 4 types. Okay, so there is no problem in this because of different representations. And next, coming to the third one, which I discussed already. Okay, now the next one you have to take as assignment, or just practice this question, note it down. Int class test public static void main string args int a equal to some number, int b equal to some number. Now long c equal to a plus b. Now I'm adding a and b and storing in long, as storing in c, which is a long type. Okay, now do we get any error here? Remove these two. First of all, remove this and check the output. Okay, after that remove these two, and similarly these two. Okay, whenever you remove these two, keep these two forward slashes for another one and check it, otherwise you will get error for multiple declarations. Okay, now here long, just check it, the same similar type of question I'm explaining you here. This one, I'm giving int a, I'm declaring a as int. And now this one, as I told you here, that is 10 by 3, which is equal to, actually this must be equal to 3.33333. Okay, it is equal to 3.333333. But here this is stored as 3.00000. We get output like this. Okay, instead of 3.33 always, we will get 3.0, because integer by integer is an integer. Here we need a typecasting operator, so we use float a by 3. Now this one, if we check this one, a by 3, a by 3 is also 3.003, just 3. Now here, then it is converted to float, which is 3.000. Okay, and assigned to b. This is also similar case, a by 3 is 3 and 3 should be assigned to float, and here 3 is an integer, this is an float, so I am assigning integer to float. So there we need a typecasting operator, but here this is a widening conversion, so it is implicit, it is done by compiler, and also we can do it by using this float, this one. Okay, next, coming to this one, this is a special case. Now this is where our output will be right. Okay, now float b equal to float of a by 3. Now here what happens is, first a is converted into, sorry, first a is converted into float, like 10 10.0000000, and this is divided by 3. It means that now this is float, right, and float by int. Okay, now float by int is equal to, obviously, which is float, so it stores 3.33333. Okay, so this is the right case, this one is the right case. Okay, this come to end of our type conversions. Okay, let's let's move on to another topic called, what is our another topic? Keyboard. How to read data from keyboard. How to read data from keyboard. We have two methods here. We can read using scanner class, which is a predefined class, scanner class, and also buffered reader. Buffer reader or input stream, using input stream. Okay, we will discuss these two in our today's topic also. Okay, now coming to scanner class. First, scanner is a predefined class which is in util package. For using this scanner class, we have to import util package. Okay, now which is used this scanner class. I told that reading from keyboard. Okay, so this can be used to read from keyboard, and it also can be used to read from some file or some scanner objects and so on. Okay, we can use data from internet also using scanner class, and we'll discuss file as well in our future classes. Now, how to use scanner class? Now, scanner is having these methods. Okay, scanner is having these methods: public int, next int, public next float, here next double, next line, boolean. Okay, now this is used to read the int. Next int is used to read here integer. This is used to read integer value, and next float is used to read float value. Here this is for double, this is double, this is string, this is also string, this is also boolean. Now what is the difference between next and next line? Okay, these are both are strings, but what is the difference between next and next line? Here next line takes only one word of string, one word of string, but string next line takes, it might take paragraph or one line. Okay, whatever the data you give, we will see one example on this after some time in this session only. Now creating, how to use it. Now creating object, because scanner is a class and it is having all non-static methods which cannot be accessed with the class name, so we have to create object. So how to create object? How to create object? This is the syntax for creating object. Here we are using new operator. Here we are using new operator to create object. Simple, this is very simple actually. Here this is the class name followed by variable name equal to new, and again class name, and it's actually, this is not a class, actually it's class name, but it's a constructor with parameters are arguments. Okay, this is a creation of object. Now this is class name, variable name, new operator, class parameters. This is constructor. This complete is called class with parameters, is called constructor. Okay, now here I'm giving source path from where we are going to take, like file or keyboard. Now here I'm using keyboard, right? So I'm using keyboard. For that we have a text predefined one, which is system dot in. This represents keyboard. Okay, system dot in, this is keyboard. Okay, now let's see an example on it. Scannerless. Okay, now import java.util.scanner. We have to import this one, and next, okay, we will see this in a notepad, separate notepad. File, save, and where we are saving Java program, right? Now here this is scanner demo dot java, all files. Okay, save. Now I saved it as scanner demo dot java. Now see here, I will explain the code once. Here scan equal to new scanner of system dot in. Here I am creating object of scanner class. Okay, and after that I am reading two values, two integer values. Am I adding them? Okay, now let's compile it. Now java c scanner demo dot java, compile fine. Now java scanner demo scanner demo. See, enter any two numbers. It's asking for enter any two numbers. Okay, now I'm entering it, like 10 and 20. 10, enter 20. What is the output? Sum is 30. Or else you can give like this also. Now I'm again executing it. 10 space 20. Okay, you can give it in two ways, either like this or like this. Okay, here I'm giving 10 entered 10. Here I press enter after 10, but here I press enter after 20. Okay, you can give it in either ways, no problem. We'll see next example. Okay, this one, this. Okay, now import java.util.scanner class scanner demo. Here also, here I'm using string. Okay, control C. Now class scanner demo. Here also I created object, and dot is a member access operator. Okay, here dot is a member access operator. Here also member access operator. So I'm using dot operator, and scan is a reference variable, right? Which points to scanner object. In that scanner object we can use many methods which I have told you just now. Next end, next line, next float, next double, next char, next boolean. Okay, now here I want to give you difference between next and next line. These are two names. For first name I will give you two words, and the second name also I will give you two words. Okay, let's see what is printed. Now go to command prompt. Now first compile it. Compiled fine. Now enter any two names. Now here I am giving some core space Java. Sorry, it took at AI. Now core, enter. Wait a second, what happened? Enter any two names. Core. Okay, next line is not working here. Let's try like this. Core Java Chandu. Let's see what happens. See here. Now it took core as 1 and Java Chandu as 2. You will get more clarity here. Okay. Core space Java dot. I'm giving one space dot Chandu. Okay. Now see spaces here. Okay, see spaces. For that reason, I gave you space here. For that reason, I give you space in this place. Okay, n1 space n2, n1 bigger space, and then Java Chandu. It is taking core as one part and Java Chandu as one part. Okay, this is the difference between those two. Next, we have buffered class. Okay, buffered. Take this example. When we create scanner object, what happens is now scanner object holds system.in, right? And here it is having address for system, so it holds system.in. And next, input, where this input is taken from. Now system, as I told, system is having print stream objects, right? Which is a print stream class. Now it has input variable and output variable. We used output variable as system.out.println and so on. So now here I am using input in. Okay, here in is holding the address of input stream reader object or input stream object. Okay, now in that it holds address of input stream object. Now here in this input stream, a read method is called. Okay, read method is called. This will hold the address of keyboard. This will hold the address of keyboard. Okay, so when the scanner object is created, a reference variable is created. Memory is allocated for reference variable, and this reference variable holds scanner object, which is having address of input like system.in, where we need to take input, and it in between this system, in is a variable of system class, right? This is a static variable. That is why we use system print system class name. Okay, now here this is the input object. Okay, now this input object holds the address of input string, which internally points to read method, and this read method is called, and this read method holds the address of keyboard. Whenever we press any key, this read method takes the input and pass it to scan object. Okay, this is about scanner, and now we will see how input is taken without using scanner class. Now this is the example. Hmm, okay, now here see, I'm using input stream reader as well as buffered reader. Okay, input stream reader and buffered reader. Here, okay, here I'm using two classes rather than one, input stream reader classes as well as buffered reader class. Okay, so instead of using these two, uh, class is predefined. The scanner class is predefined, which internally uses these two things. Now here it uses input stream, right? The scanner uses input stream. Here we are explicitly using, there we are explicitly using only scanner class, which implicitly uses input streams. Okay, now here system.out.println, enter two names. Here here buffer reader having a method called read line. Okay, buffer reader having a method called read line. That read line method is used. Okay, here, and also this we will see in wrapper classes, where okay, this we will see in wrapper classes. Integer.parseInt, this parseInt method, okay, which throws an exception actually. We okay, so here we are adding two strings, two numbers. Okay, parseInt method, integer. Let's see the output of this. Sorry, cancel. Where we are writing the Java programs, right? Here, what is the program name? This is buffered reader. B BUFFERED reader dot Java. Okay, you can save it directly or you can use all it. Save it. Now open command prompt. Now Java C space buffered reader dot Java. Sorry, buffer reader dot Java. Now it's compiled fine. Now Java. buffered reader. Now could not find, sorry, this is not our buffer reader demo, I think so. Our class name is buffered reader demo, right? Okay. Now in this Java buffered reader demo, now it's asking enter any two numbers. Okay, now I am entering 30 and one more number is 20. You will get 50. Sum is 50. Okay. Now we are without using scanner object, we are using it, right? We are there. We did it. Okay. Now see this. Here, first input stream reader object is created. Uh, Consider it as input stream reader object. Input stream reader object and a buffered reader object. This is buffered reader object. This is BR. Okay. Now I am giving this value. I am giving this input to this buffered reader. Okay. And I am using wrapper classes. See here, input stream ISR equal to new input stream reader of system.in and buffered reader BR equal to new buffered reader of input stream reader, this one. I am giving input stream reader to buffered reader object. Okay, and from here using this buffer reader I am reading input from read line using read line method and also pass in the wrapper classes methods. Okay, these wrapper classes are there in java.lang package, so we should not we, no, we will not import them. Okay, now this comes into our type conversions and reading data from keyboard with and without using scanner object. We'll go for control statements and loop control statements in our next lecture. So please subscribe and like my videos.